Okay, let's talk about compressions and stretches here. Okay, so for this example, I'm going to use the absolute value graph, so the V graph here, right? And what we're going to do is we're going to multiply by a number, right? By A being positive or negative, we're going to see how that affects the graph. So right now I have A is set to 1, and we'd expect to see the general old V graph here, right? So, but as A increases, right, to 2, notice the graph got sort of skinnier, right? And then the more that we increase the value of A, sort of the skinnier the graph kind of gets here, right? So the further out I go, the skinnier it gets. So I'll bring it right back to 1, right? So if I multiply a function, right? So A times, oh sorry, so if I multiply A times f of x, any one of my parent functions, and A is greater than 1, that is going to imply I'm going to have a stretch. Alright? But what happens if A is in between 0 and 1? So kind of like a half, right? Well, now all of a sudden I have a compression, right? Because I used to have this graph going on when A was equal to 1, right? If I move that back when A is 1. But now, since it's in between, I have a compression. So if you multiply by a fraction in between 0 and 1, you get a compression. I don't think I spelled that right. I'm not sure. That's okay. Alright, so let's consider this one, right? Let's consider the Hurley graph. If I multiply by A here, okay, so if I set A to 1, I have the regular old Hurley graph. But if I increase the value of A, notice that my graph gets stretched out, right? If I go back to 1, if I go to the negative, right, it goes to 0 there, of course, and then if I go to negative land, it gets a reflection, which I'll get to in the next section. So for the Hurley graph here, right, the more I multiply by, the more stretching I get. So that's a stretch. All right. Okay, let's see. Do I have any more? Let's do another example. I think that'll help it out. Let's do this one. Let's do f of x is equal to x squared. So that's the general old parabola, right? Now, what if I do f of x is equal to 1/3 of x squared? Okay. Well, 1/3. That means that I'm multiplying by a positive fraction, so that graph should be compressed out. So here we go. When I go like that, you can see that it's a little bit wider, right? A little bit wider. So what if I multiply by f of x is equal to 3x squared, right? Well, that should give me a stretch, and if I put that onto the graph, it stretches it, makes it a little bit skinnier, okay? So there are compressions and stretches that can be done to our functions there.